Okay, 1.4, we are solving linear systems. This section will be a challenging section. That's okay. Just like anything, when we practice, when we work hard, we'll get through it. Okay, let's go right down here to this first exploration. It says, match each linear system with its corresponding graph. Explain your reasoning. Then classify the system as consistent or inconsistent. Okay. So first things first, we have these equations, and I'm just going to look at A. We have those equations of lines, okay, but they're not in my preferred equation. They're not in slope-intercept form. You know, y equals mx plus b. So I'm going to put it in y equals mx plus b. I'm going to take that 2x minus 3y equal 3, and I'm going to put it in y equals mx plus b. To do that, I just have to subtract the 2x over, and then I have to divide by that negative 3. Okay, so the first one is y is equal to 2/3 x minus 1. That's that first equation. The second one, negative 4x plus 6y equals 6. Again, same thing. I get 6y equals 4x plus 6 divided by 6. I get y is equal to 2/3. Right? If I simplify 4 over 6, I get 2/3 plus 1. Okay, now, when I look at my two lines in slope-intercept form, I have the same slope, right, 2/3, but they're at different y-intercepts. So that's the first equations. The answer is B. The second one, same thing. Okay, I'm just going to 2x minus 3y equals 3. Get it in slope-intercept form. Negative 3y equals negative 2x plus 3. Divide by 3, you get y equals 2/3 x minus 1. I'll write that over here. Okay. The other one, x plus 2y equals 5. We get 2y equals negative x plus 5. Divide by 2, we get y equals negative 1/2 x plus 5 over 2. Okay, looking at that, looks like that's going to be C. C. And the last one we don't even have to do it. It's just going to be A. They're the same exact line. Same exact line. So we're going to say A. Good. We solved those three. Now, scrolling down here, it says solve each linear system by substitution or elimination. Then use the graph of systems on the next page to check your system. Okay, whatever. I forgot one thing up here. I forgot to say if they were consistent or inconsistent. Okay, so going back, this was B, this was C, and this was A. Consistent. A system is consistent when it has at least one solution. What does that mean? If it has one solution, it means they intersect at least one time. So this first one, these two lines in B, do those ever intersect? No. So it is inconsistent. In graph C, do they ever intersect? Yeah, right there. So they're consistent. In A, where do they intersect? They intersect a bunch of times. Okay, at least once. So yes, this is consistent. Okay, now we can move on. Solve each linear system by substitution or elimination, then use the graphs. Okay, so I'm going to show you this in two different ways, both substitution and elimination. Okay, substitute. Can we solve for one of these equations for one variable in A? Can we solve for one variable in one of those equations? Yeah, we can. I'm going to take this equation right here, x minus y equals 1, and I'm going to solve for one of the variables, x or y. I'll solve for x. How do I do that? Well, if I add y to both sides, I get rid of y, and I get x. So x equals 1 plus y. This is substitution. Okay, I'm going to take that x, and I'm going to take this equation here, and I'm going to plug in x. 2, what does x equal? 1 plus y. Plus y equals 5. Now solve for y. I have to distribute the 2 plus 2y plus y equals 5. I get 2 plus 3y equals 5. I get 3y equals 3. And I get y equals 1. And now I have to solve for x. How do I do that? Well, I can plug y into either equation. I'll just plug it in right here. X minus 1 equals 1. Add 1 to both sides, you get x equals 2. That is substitution, where we solve for a variable and then plug it into the other equation. Next, I'm going to use elimination. Sorry, over here we got what? X equals 2, y equals 1. If I go down here for letter A, where do those points interact or intersect? At point 2, 1. That's what we're solving for. We're solving for where do these lines intersect? 2, 1. So my next answer for B should be at negative 2, 1. And we'll see if that's what we get. Using elimination. Okay. Elimination. I'm just going to rewrite both these equations. X plus 3y equals 1. Negative x plus 2y equals 4. And I'm just going to add these equations together. Just add them together. What's negative x plus x? Nothing. It's 0. We're going to cross those out. What's 3y plus 2y? 5y. And then what's 1 plus 4? 5. Divide by, here we have a new equation, 5y equals 5. If we divide 5 on both sides, we get y equals 1. Now, we're just going to take this and plug it into one of these equations up here. One of these two. I don't care which one. I'm going to choose the top one. X plus, not x equals. X plus 3y, or 3 times 1, equals 1. X equals, I did that again. X plus, not x equals. X plus 3 equals 1. Subtract 3, we get x equals negative 2, which is exactly what we should have. Negative 2, 1. Okay. C, you can use any method you want. Substitution or elimination. I'm going to use elimination here. Why? Because this is a little trickier. Okay. And elimination will come in handy later on. We have x plus y equals 0, and 3x plus 2y equals 1. Okay, and if I added those together, okay, I just got 4x plus 3y equals 1. I didn't help out a thing. That did not help me out.
Okay? That does not help me out. What do I have to do
To make sure I eliminate a variable.
That's what I'm trying to do. I'm trying to eliminate either x or y. I have to multiply. If I want to eliminate the x,
I need a negative 3x.
if I want to eliminate the y, I need a negative 2y. So I need to multiply this equation by something. Either negative 3 or negative 2. Multiply by negative 3. Okay? Then in my new equation, I'm going to get negative 3x minus 3y equals negative 3 times 0 is just 0. Okay? And then I'm going to take that other equation, 3x plus 2y equals, is it 1? Can't see. Equals 1. Now we're going to add those together. What did I just do? I eliminated the x. Negative 3y plus 2y is negative y equals 0 plus 1, 1. Y equals negative 1. Now, go ahead, plug that into the equation. I get x plus y, or negative 1, equals 0. Add 1 to both sides, you get x equals 1.
And that's elimination and substitution. How can you determine the number of solutions of a linear system?
If the graph, if the lines are parallel, then no solution. If they intersect at least once, then there is at least one solution.
Number 4, suppose you were given a system of 3 linear equations and 3 variables. Explain how you approach solving each system. Well, I'm going to go through that right now. And there is a special way we have to do this. We have to do this by elimination. We have to. Okay, with 3 variables and 3 equations, we can solve. If we have 3 variables, 3 equations, we can solve it.
What I want to do is I want to find 2 equations that will eliminate each other right away. 2 equations that either eliminate the x, the y, or the z. I don't care which one, x, y, or z. I'm going to choose the x. Okay, I'm going to take this equation and this equation, just because x comes first. That's what I'm going to choose. I'm going to choose those 2 equations. X plus y plus z equals 1. And my bottom one, negative x minus y plus z equals negative 1. And I'm going to add those together. And I actually lucked out here because x's cancel out, y's cancel out. I already solved for z. 2z equals 0, z has to equal 0.
That's not always the case, so we'll go through some more examples here shortly. Next, let's eliminate the y. Let's eliminate y. Let's take this equation 2. We haven't used that yet. And let's take these first 2 equations. X plus y plus z equals 1. Well, actually, we already know what z is. It's 0, right? So I really don't even need that. And then we have x minus y equals 3. Add those together, I get 2x
equals 4, x equals 2. Almost done. I have 2, I have 0, I need to solve for y. Plug that into any equation. Top equation is 2 plus y plus 0 equals 1. 2 plus y equals 1. Subtract 2, y equals negative 1.
Solve for x, y, and z. Now, your final answer. Your final answer. I want you to write it like this. Big parenthesis. We have x first, then y, then z. We will go through more examples. These are extremely tricky, extremely difficult. It's okay. We're in math. We expect this. Okay, let's go down to another example. Elimination. First thing you want to find, does any variable cancel itself out right away between two equations? Look at our x's. Do I have any opposites? Nope, x, 2x, and 4x. No opposites there. So I'm not going to use x right now. How about y? 2y, y, and 3y. No opposites there. How about z? Negative 3z, negative 2z, and positive z. No opposites there. Okay, so we have to come up and manipulate this graph. First things first, we're going to choose two equations. I'm going to choose these two right here. Okay, x plus 2y minus 3z equals 11, and 2x plus y minus 2z equals 9. And I want you to choose which variable do you want to get rid of, x, y, or z. I want to get rid of x. That's just how I work. I want to work left to right. I'm going to get rid of x. But you can choose any variable you like. To get rid of x, I need an opposite. I need this top x to be negative 2x. So I'm going to multiply by negative 2. I have to distribute that negative 2 to each piece of that equation. So I get negative 2x minus 4y plus 6z equals negative 22. And the bottom equation stays the same. 2x plus y minus 2z equals 9. Add these together. X is canceled out. Perfect. I have negative 4y plus y. That's negative 3y. I have 6z plus negative 2z. I have plus 4z. And negative 22 plus 9 is negative 13. Okay. Next thing we have to do, star this equation. We're going to come back to this equation. Just not right now. I use those top two equations to get that first negative 3y plus 4z equals negative 13. I have to, my next step, I have to use my third equation. And I have to get rid of x in order for this to work. So I have 4x plus 3y plus c equals 16. I don't care which equation you use, the top or second equation, I do not care. But we have to, again, multiply and manipulate these equations to get rid of a variable. Let's see. I'm just going to choose the second equation. So 2x plus y minus 2z equals 9.
Now, I have to get rid of x. I got rid of x the first time, I have to get rid of x this time. Down below I have a 4x, so I need this to be negative 4x. So I need to multiply that top equation by negative 2. Running out of room here, I'll go up top. I get negative 4x minus 2y plus 4z equals 9. Or no, equals negative 18. Ooh, almost made a mistake. And then I have 4x plus 3y plus z equals 16. Add those together. Those cancel out. Negative 2 plus 3 is just 1y. And then 4z plus z is 5z equals negative 18 plus 16, negative 2. Okay. Now, I have two equations with y and z, which is what I want. I got rid of a variable, I got rid of x. We're going to combine those two equations together. So, y plus 5z equals negative 2. Got that from up here. And then I'm going to write the other one, negative 3y plus 4z equals negative 13. Again, I have to solve for one variable. I'm going to solve for y. To do that, I need this top equation to be a positive 3. So I'm going to get, let me erase this right here. I'm going to get 3y plus 15z equals negative 6. I'm going to have negative 3y plus 4z equals negative 13. Add those together. Cancel out, we get 19z equals negative 19. Z is equal to negative 1. We are extremely close to done. Once we find a variable, we can just plug that in to one of these two equations, either this one or this one. I'll plug it in right here. We have negative 3y plus 4 times negative 1 equals negative 13. We get negative 3y minus 4 equals negative 13. We get negative 3y, add 4 to both sides equals negative 9. We get y is equal to 3. Almost done. Now we just have to plug those two into one of our original equations. I'm just going to go with this top equation. X plus 2 times y, which is 3, minus 3 times z, which is negative 1, equals 11. Solve, we get x plus 6 plus 3 equals 11. X plus 9 equals 11. X equals 2. My final answer has to look like this. X was 2, y was 3, and z was negative 1. Okay. We're going to be going through some more of these in practice. Okay. Right now, this is all I want you working on, the elimination method. Okay. Down here, no. No, that's it. Okay.